All right, so in this video, we are going to go over a study guide for the Math 2 final. It's going to be very similar to the study guide that we did in class, but it's going to be more example problems. Okay, and just to refresh, these are the specific things that are going to be in on the final. Exponential, polynomial operations, factoring quadratic expressions, using the quadratic formula, being able to analyze and graphing parabolas, being able to identify the three forms, and being able to plot parabolas. Okay, so starting off with exponentials and radicals. Um, Here it is, question one. We want to be able to write the expression in exponential form, so we want a base and we want an exponent. So what we want to do first is we want to do this one step at a time. We want to convert the inside of my parentheses as an exponent. This will become 11 to the power of 1/4. Okay. Now we have an exponent raised to an exponent, so then our next step will be 11 1/4 times 3. And then when we have a fraction times a number, we only multiply the 1 and the 3, so this becomes 11 3 over 4. Okay, now when I want to simplify the expression here, um, when I want to simplify, this just means I don't want any negatives in my expression. So here we're going to make this equal. We're going to set up our fraction, and then we're going to do one at a time. M to the fourth, this is a positive fourth. So if it's a positive 4, if it's a positive exponent, we do not move it from its location. So this stays as m to the fourth. Let's cross it off so we know we did that one. Now we're going to do n to the negative 2. That one has a negative exponent, so let's see. This one has a negative exponent, so we need to move it. It goes to the bottom, and when I move it, it becomes a positive exponent. Okay, now we're going to do p to the third power. No, the third power, that's a positive 3. I do not need to move it. It stays exactly where it's at. So since it's in the bottom, I keep it in the bottom. Okay, the rest of the problems are very similar, but let's do question 3. So we're going to do the same thing. Here, we're going to do the inside first. So the outside stays exactly how it is, but the inside, we're going to write it as y 1 over 8. No, 1 over 3. 1 over 3. Okay. Next, we're going to do 1 over 3. And then we're going to multiply by 8. When I have a fraction times just a number, this becomes y 8 over 3. Okay, and let me do question 6. Question 6. Okay, so here we're going to set up our equals and my fraction, and we're going to do one at a time. This 4 has a exponent, a positive 1. Every number has a positive 1 exponent. So if that has a positive exponent, we keep it where it's at, 4 to the 1. Let's cross it off. Now let's look at x. X has a negative 3 exponent. What we're going to do is We're going to write it in the bottom. We need to move it. It has a negative exponent. We move it. The only other place I can move it is to the bottom, and we cross it off. Next, we're going to do y to the fifth. Y to the fifth is a positive exponent. I do not need to move it. It stays as y to the fifth, and it stays on the top. Okay, now let's do 16. 16 again has a positive exponent. Positive exponent. So I do not need to move it. Okay. Now z. Z has a negative 2 exponent. The only other place I can move it is to the top. My z to the second power goes to the top, and when I move it, it becomes a positive exponent. Okay. Now here we can go further. We have 4 on the top, 16 in the bottom. We could reduce this as 4 goes into 4, but here 16, that's going to become a 4. Right? 4 goes into 4, 4 goes also into 16, so this reduces to y to the fifth z squared all over x to the third times 4. Okay. You can also rewrite it as y to the fifth z squared all over 4x to the third. Okay, moving on to polynomial operations. Here we want to simplify the expression for all of these problems. So let's start with number 10, and then I'll leave 7 for you guys to do. It's a little bit, 7 and 8 are a little bit easier to do, and we'll see why. So here, I do not have any numbers in the front of my parentheses, so I do not need to distribute anything. But here, in front of this negative, or in front of this parentheses, or this expression, I have a negative. I want you to write an invisible one there. Okay, that negative one, I'm going to multiply to every single term inside. Okay, now here, I also have an invisible one, but this is a positive invisible one because I do not have a negative in front. So it's a positive one. And since it's a positive one times negative 3, that stays as a negative 3. Positive 1 times positive 4, that stays as a positive 4. Positive 1 times a negative 5 stays as a negative 5. So nothing really changes in the first one. So we could write 3x squared plus 4x squared minus 5 for the first set. Now when I distribute, I'm going to have negative 1 times positive 2. That becomes a negative 2x to the third. And then a negative 1 times a negative x squared. That becomes a positive x squared, negative 6x, positive 1. And now we're just going to be combining like terms. Starting off with the highest exponent, I have negative 2x to the third. I cannot combine it with anything else. Okay, now let's cross that off. So I know I combined everything. Now we're gonna do x squared. I have negative 3. Oh, there is a typo here. My mistake. This is x to the third. We could combine stuff. So this should be negative 3x to the third and minus 2x to the third. So this becomes not this, but negative 5x to the third. Let's combine that. Now we could continue. 4x squared, I can combine it with this 1x squared for 5x squared Next, there's negative 6x. I can't combine it with anything else. Stays as negative 6x. And then plus 1, and this minus 5. That gives me negative 4. And that is my final result. Okay. Okay. I do want to do question 7. That way we have one example of each. So going over question 7, here we have a positive 1 and a positive 1 in front of my parentheses. When I distribute that positive 1, it does not change any of my numbers. So we get 2x squared minus 4x plus 1 plus 5x squared plus x minus 3. These 3 came from these 3, and these 3 came from this 3. Now we can combine like terms. This 2x squared, I can combine it with this other x squared to get a total of 7x squared. Cross that off. There's negative 4x. I can combine it with this 1x. Negative 4 plus 1 gives me negative 3x. Cross that off, 1 minus 3, I get negative 2. Okay, so that would be it. Looking at the bottom problems, let's see. Question 9 and 12. Let's see. Let's do this one. Let's do question 12, and then I'll let question 19 be for you guys. So question 12, I want to simplify the product expansion. So what that means is I need to multiply and then I need to simplify afterwards. So here I have a 2-term times a 2-term. So binomial times binomial, there is 2 terms. I'm going to be setting up a 2 by 2 terms. 2 by 2 box. We're going to set up a 4x plus 3, and then a 2x minus 7. It does not matter what side they go on for this case. So let's multiply these two. 2 times 4 gives me 8. X times x, in total I have x squared. 2x times 3 gives me 6x. 4x minus 7 gives me negative 28x. Negative 7 times 3 gives me negative 21. Now I'm going to write it all together. 8x squared plus 6x minus 28x minus 21. Okay. Now from here, I can write this as, I can combine those two, and my final answer is going to be 8x squared minus 22x minus 21. That's my final answer. So for hint for question 9, here we are going to have a 3 by 2. Now here, it does matter where you put this trinomial and this binomial. Okay, so I'll leave that for you guys. Okay, so section 3, factoring quadratic expressions. So I'm going to do one problem because the rest of them are really easy. I'll give you a hint for question 15. I'll give you a hint for question 15 at the very end, but these are very similar. Here, I want you to know that this is a 1. This is also a 1. up here. Let's see. Let's do one of the harder ones. Let's do question 14. So let's do question 14. So what we want to do is there's a couple ways you could factor this. I'm going to show you one way that always works. So what we need to do is we need to do the diamond method first. We need to do the oh, let's see. Why did it stop working? There we go. Okay. I'm gonna show you one way or that always works. So what we want to do is we want to multiply my first and my last. My first times my last, 3 times positive 6, that gives me 18. This negative 11, your middle term, it's going to go on the bottom. 11. Okay, so we need two numbers that multiply to 18 but add up to negative 11. Here we are going to go with negative 9 and negative 2. Okay, with these two numbers, let's see. With these two numbers, I'm going to rewrite my expression. I'm going to rewrite it as 3x squared. And since these are replacing the middle term, it's going to replace this. Instead of writing negative 11, I'm going to write negative 9x minus 2x plus 6. So these two numbers are replacing the middle number. Now, from here, we want to set up a box. This is called factoring using the box method. Notice that I have 4 terms, 1, 2, 3, 4, and I have 4 boxes, 1, 2, 3, 4. We're going to use that to fill in my box. We're going to have 3x squared minus 9x minus 2x plus 6. Okay, so when I factor, what your product is going to be, it's going to be what we write on the outside of my boxes. So here, I don't like to worry about the negative sign or the positive sign. I just want you to do the numbers first. So here, what can I take out between 3 and 2? Only 1. And since this one has an x and this one has an x, I can only take out one of the x's. I can take out x squared from this one, but this one does not have x squared, does not have two x's for me to take out. So I take out only one. Okay, now looking at this row, I can take out a 3 and I cannot take out any x's. I can take out an x from the top one, but not the bottom one. So I can only take out 3. Next, between 3 and 9, I can take out a 3 and I can take out one of the x's. Now here, between the 2 and the 6, I can take out a 2. Okay, now here, now we need to worry about the negative or positive signs. Here, if I have positive 3 times positive 1, I am getting a positive 3. Now, if I do positive 3 times positive 3, I am not getting a negative. Which one of these should have a negative sign? It cannot be this one, because if I change this one, then now that this one becomes a negative. And I don't have a negative there. So I need to put the negative there. Here. Okay, now we're going to do the next one. 1x times 2, that gives me a positive 2x. That's not what I have here. So then to make it a negative, Again, I cannot change this one. I need to change the sign on this. So this one becomes a negative. And to make sure we did this correctly, a negative 2 times a negative 3 should be getting us a positive 6. Okay, so then our final answer, writing this as factor form, we're going to have 1x, so x minus 3, and 3x minus 2. Okay, and that's my final answer. For question 15, we could do this a couple ways. You could recognize that that this is a difference in squares. If we do not know what that is, this method still works. It's gonna cost you a little bit more time to solve. But if we do not want to remember what difference in squares is, or we forget or we blank out during the quiz, we can always use this method. Here, we want to rewrite it as y is equal to 9x squared plus 0x minus 16. Here, just notice that we have 0 to x's. So then when I do my cross, I have 9 times negative 6. That's a huge number. But on the bottom, we're going to have 0. Okay? So that was your hint for question 15. The rest of these problems, they are very, very similar to this one. Very similar. So I'll leave the rest for you as practice. There are definitely going to be a couple of these questions. Okay, so section 4, solving using the quadratic formula or via the quadratic formula. What we want to do is, let's see, all of these problems are very similar. So let me just do question 19. Let me do the first one. Okay, question 19. What we want to do is, notice that this is not equal to 0, meaning it's not in standard form. So what we need to do is we need to get everything on one side of the equation. What I can do is I can move this 3x squared plus 7x or this minus 7x and just move it over to the other side, or I can bring this negative 2 over. It does not matter. At the very end, we should be getting the right answers, or the correct answers. So I'm going to move this negative 2 over. And what I mean by that is, how do I cancel this negative 2? Well, I need to do a positive 2 and then a positive 2. I cannot combine this positive 2 with this 3x squared. I cannot combine it with the negative 7x. So it's going to stay as a positive 2 on the left side. On the right side, a negative 2 and a positive 2 is equal to 0. Okay, so here we want to set it up every single time. Every time. One side should equal 0. And now from here, we can find my A coefficient, my B coefficient, and my C coefficient. A, B, C. A is 3, B is negative 7, and C is 2. Now, we just need to plug it in into my quadratic formula. Oh, my quadratic formula up here. When I plug it in, I want you to use parentheses, meaning we're going to have x is equal to negative parentheses b plus or minus the square root of negative b, or b negative 7 squared minus 4 times a times 2 all over 2 times a, which is 3. Okay, so on your calculator, I don't want you to do everything all at once. What I want you to do is just focus on the inside of your square root. So when you type it into your calculator, it's pretty hard to see. You're going to be typing parentheses negative 7, and then you're going to have exponent 2 minus 4 parentheses 3 parentheses 2. So notice that I put all of the parentheses into my calculator. I want you to do the same thing. Here, my calculator has a function to put it as x squared. I think yours does too, or if not, you can use, there's a arrow on your calculator. This means exponent. And then you would be putting arrow and then 2 afterwards. So that would be an exponent of 2. But anyways, make sure to type in all of the parentheses. Make sure you are putting it correctly. We did not plug in the square root. We only plugged in the inside of the square root. Press enter. We get 25. Okay, so that means when I am simplifying, meaning I'm going to rewrite all of this all over again, I know what the inside of my square root is, 25. Now here we can also do some more simplification. A negative times a negative, that becomes a 7 plus or minus. We know the inside of my square root, it is 25 all over 2 times 3, that is 6. Now here, when I want both of my answers, this is where I need to split this. I need to split this. One of them is going to be 7 plus the square root of 25 over 6. The other one is going to be 7 minus the square root of 25 over 6. Okay? When I plug this into my calculator, I'm going to do 7. I'm going to do this one first. Let's see. 7 plus the square root of 25. Okay? Press enter. You're going to get an answer. You're going to get 12. You are not always going to get these nice answers, so make sure to type in the top first. You're going to get an answer, and then just divide by 6. That is your answer. 2. Do the same thing for the next one. We're going to type in the top 7 minus square root of 25. Press enter. Divide by 6. Here I'm getting a fraction. It's going to be 0.33. So this one is 0.333, and then continues forever. These are my 2 answers. We will not be tested on discriminant, but you will be tested on how to use the quadratic formula. So for all of these questions, they are not written in standard form. So what you need to do is you need to move all of the terms into one side of the equation. It does not matter what side. It does not matter what side. At the very end, we will be getting the exact same answers. Okay? So here, we need to move this 8 over. Here, we need to move this 4 over, this 4x squared. here the 8x, here the x squared, here the 4x. Okay? All of these problems are very, very similar. The process is exactly the same. Okay? Simplify the inside first by plugging it into your calculator first, so you know what goes inside your square root, and you don't have to keep writing this huge um, expression. Okay. Okay, for section 5, analyzing and graphing parabolas. The vertex, when it is given to you in vertex form, is the last two numbers you are given. -2, the inside of your parentheses, and the number right outside. This 2 does not matter for finding the vertex. It does not matter. It's only whatever it's inside and the number being added or subtracted on the right side. Here, this -2. This is a liar. Liar. Do not trust it. It is telling you it is a -2. Do not write -2. When you write the vertex, you're going to do the opposite of what the liar is telling you. You can do +2, and then this -8. This -8 is not inside the parentheses. I do not treat it as a liar. You do exactly what it says. 2, -8. That's it. So here, the vertex for this one would be -3, -9. For this one, it would be -4. Oh, no. +4. Right. It's a liar. Do the opposite. +4. Okay. So all of those are the vertex. Okay. Now, we want to expand the equation into standard form. So what that means is I do not want to see any parentheses. So if I were to look back at section 3, this is expanded all the way. I don't see any parentheses. I don't see any distribution like I see up here. It's in standard form. That is what I'm looking for part B in this section. So how do we do that? So here we're gonna have to write super tiny because I did not give you guys enough space. My apologies. But what we're gonna do is we're gonna get our function 2x minus 2 squared minus 8, and I'm going to rewrite this. This is equal to 2x minus 2. Now here, this square, that means this is being multiplied by itself 2 times. And then I see how this minus 8 at the very end. Actually, let me do that one in black. Here, we need to FOIL this out there, and I have to distribute this 2 over. There is no way, there's a couple ways you could do this. I like to just do it from the left to the right. So 2 times x, that gives me 2x, 2 times -4, -4, x minus 2, and then I have this minus 8. Next, I'm going to FOIL this product. If you want, you could do it on, you could get pieces of scrap paper, and you could do the box method. You do 2x minus 4, x minus 2. FOIL this out, you get x times 2x, 2x squared, x times -4, -4x, 2x times -4, -4x, and then negative 2 times negative 4, I get positive 8. So 2x squared minus 4x minus 4x plus 8. Combine these two, I get 2x squared minus 8x plus 8. Okay? So then I have parentheses. No, not even parentheses. Just 2x squared minus 8x plus 8. Minus the 8 at the very end. So when I simplify this, I'm going to get 2x squared minus 8x. And then we have 8 minus an 8. That is a 0. That is a 0. Okay, that's it for part B. For part C, you want to find your y-intercept. The reason why we did part B is to find the y-intercept. The y-intercept, it is always given by your last number of your standard form. Meaning, this is given by 0. Your first number is always going to be 0. Your second number is always going to be your last number here. In this case, it just happened to be 0, 0. So now we're going to start plotting this. We're going to plot the vertex and the y-intercept for this. So the vertex, we said it was 2, negative 8. 2, negative 8. Right there. For my y-intercept, we're saying this is 0, 0. That's right there. Now here, we can start graphing, but I want to do a little bit more. We know that my axis of symmetry always goes through my vertex. Now here, my vertex is at 2, negative 8, 2, negative 8. My y-intercept is 2 places away from my axis of symmetry. If I want to reflect this, if it is 2 away, I'm going to reflect the 2 away. So I'm going to make another point here. Okay? And now this will become my parabola. Let me put it in blue. Oh, you guys could probably draw it better than me, but it's going to look something like this. And that is my parabola. The important thing is being able to find the vertex and the y-intercept right there. Okay? The rest of these problems are very similar. Write it in standard form. You're gonna write it as, you're gonna have y, and then you're gonna get something x squared, something x, and then something. Your last number is going to be 0. That is your y-intercept every single time. Every single time. So you're gonna get y is equal to something x squared, something x, something at the very end. That very last thing, that is your y-intercept, 0, comma, something. Okay. Okay, so section 6. Being able to write the 3 forms from a graph. This is going to be a big problem on your final. Can you do these 3? These are going to be the questions that are worth the most. Because it involves a lot of things. So, factored form. This means we are going to write it as boop, boop. We are also given that a is equal to 1. So we do not need to worry about a number in the front. It is just a 1. In factored form, when I'm looking at factored form, well, before I move on, I want you to write this in both factored form and vertex form. Do not start with standard form. This is the hardest one to figure out from just a graph. It is the hardest one to figure out from just a graph because we don't even have the y-intercept, and plus it's just super hard to find information. So what we can do is we can find either the factored form or the vertex form, and then we could find the standard form. So do not do the standard form first. Do one or the other first, and then find the standard form. So let me go over this one. Here. So factored form. Your factored form, these are your zeros. These are your zeros. So meaning here and here. This is 0. This is x equals 1. This 0 is x equals 7. Okay? What I want you to do is I want you to set these equal to 0. Meaning, set this. Move it over. X minus 7. Set it equal to 0. Same thing for this one. X minus 1. Set it equal to 0. And now from this, I want you to put this in parentheses. Put these in parentheses. That is your factored form. It's as simple as that. Y is equal to x minus 1, x minus 7. That is it. Okay. Vertex form. Now here, this one's a little bit more involved. This one, this point, it's between -8, -10, so, and it's at 4. So this point is 4 and -9. 4 and -9. On these problems, we were able to go from the vertex or the equation to the vertex. Here, when we are doing the opposite, if I am given the vertex, can you give me the equation? We already know what this number is in the very front. We are given that it is equal to 1, or if you look at question 30, we are given that it is a -1. Okay, but anyways, here, to figure this out, I want you to observe this. If my vertex is a +2 and a -8, then when I'm writing it inside the parentheses, we need to flip it because we know this 2, that should not be a 2. This should not be a +2 because the inside of my parentheses makes it a lighter. So if it's a +2 for my vertex, then when I write it into my equation, we need to flip this +2 into a -2. This -8, that stays the same. It's only this first number that changes. Meaning, when I write it in my vertex form, I know y is equal to 1, x, and I'm not going to do +4. I'm not going to do +4. I'm going to do -4. This was just a mix-up. So -4 squared -9. Okay, and that is it. That is it. Okay, looking at my standard form, you can use the vertex form to figure out your standard form, or you could use your factored form and write it in your standard form. What I think the easiest would be to do the box method for this one. So we would have x minus 1, x minus 7, multiply this out, I get x squared, negative x, negative 7x, positive 7. So I have x squared minus x minus 7x plus 7 at the very end. Combine like terms, I get x squared minus 8x plus 7. That's my standard form. And I get x squared minus 8x plus 7. Now, to double check that we got this correct, let's expand this one. So I have 1 x minus 4 squared minus 9. We should be getting the same answer. So we are not. We did something wrong. Let's see. So let's write this. This one that basically goes away because it's just a positive one. It's not going to change anything. So we could write this as x minus 4, x minus 4, minus 9. That looks pretty hard. Let's do on the side. Another box. Yeah, I would say this one's easier because we're gonna have to end up doing the box anyways. So let's do x minus 4, x minus 4. This becomes x squared. This becomes negative 4x, negative 4x, and positive 16. Okay, so then we get x squared minus 4x minus 4x plus 16. X squared minus 8x plus 16. So this inside, let me write it in a different color. That becomes this. So we have, oh, I was out of frame. So here, the box method, I'm multiplying x minus 4 times x minus 4, x minus 4 times x minus 4. Did the box, wrote the terms out, combine like terms, I got that. So I get x squared minus 8x plus 16, and then I have minus 9. Okay, combine like terms, I get x squared minus 8x, 16 minus 9, that gives me 7. And look at that, we are getting the exact same answer. So this is correct. Now on your test, make sure to be showing your work. If you go directly from this to this, I'm going to get suspicious. Okay, I do want to do question 30 together, mostly because this one has a negative in the very front. So let's see how that's going to change some stuff. We're going to do the same thing. What is my 0 here? This is x equals 1. This one is x equals 3. So set it equal to 0. So x minus 1 is equal to 0. Here, x minus 3 is equal to 0. Oh, no. There's a typo. That's an x minus 3. X equals negative 3, right? Negative 2, negative 2. So then this becomes x plus 3 is equal to 0. My two factors are this and this, here and here. Now, the reason why this one is different is because x is equal to negative 1. So when I write it as y is equal, here we were able to write it as 1 times my factors because a was positive 1 and that did not change anything, right? This is my 1. For this one, we are going to put a negative 1 in the front, and then we are going to do x minus 1 and x plus 3. That's it. Now from the vertex, again, we look at my vertex. My vertex, this is negative 1, 4. So negative 1, 4. When I write it in vertex form, I do the opposite. So we're going to have y is equal to negative. We know it's going to be negative at the very front because that is my -1. These will be given to you. So don't worry about having to find the value of a. These will be given to you. X, and then we have the +4. When I write it inside my equation, that 4 came from the y term. It's outside of my parentheses. I do exactly what it says. It's not like that -1 though. That one has to go inside here. So if I do, let me see, let me put it in a pencil. If I do -1 here, if I do a -1, that means that my vertex is going to be 1, 4. That is not the same vertex as here. So again, when you write it into vertex form, do the opposite of that -1. That -1 should be a positive 1. Should be a positive 1. That's going to make this a -1 for vertex, and that's what we have. Okay, so let's see. Now, how do I find the standard form if I'm given this? Okay, well, in this case, what we can do is you could pick one or the other. I want to do this one. I want to do this one. I want to simplify x minus 1, x plus 3, and I want to simplify this. What I can do is I can do this on the side, do the box method real quick, and at this point we should be pretty good at doing this. X minus 1, x plus 3, x squared, minus x, 3x, and then -3. So x squared, okay, I'm out of frame again. I have x squared minus x plus 3 minus 3. Oh, forgetting the x there. Combine the like terms. I get x squared plus 2x minus 3. So I'm going to get -1 parentheses x squared plus 2x minus 3. And that came from this part. Distribute that negative over. This becomes negative x squared, negative 2x, positive 3. That is what I'm going to write. Y is equal to negative x squared minus 2x plus 3. And there we go. Okay, I'll leave question 29 as a practice problem. Okay, thank you. Okay, and the very last section, another problem that will be worth lots of points. We are given three equivalent forms of a quadratic, upward quadratic. So we know it's going up. So what that means is I want you to plot the parabola, and in this problem you are going to be plotting the vertex, the x-intercepts, and the y-intercepts. And those three things are given from these three things, or these three factor forms. Each form gives you one specific type of information. Let's start with the factor form. Let's see if I'm in frame. I'll just write it. Factor form is this. When you are looking at factor form, what you are looking at is only the parentheses. You have x minus 2, and you have x minus 4. You do not even care about this, so erase it. It doesn't matter. For now. Erase it. The only thing you are going to be focusing is on these 2 points, or these two what are these called? These two products. X minus 2, x minus 4. Set them equal to 0, keep them separated. X equals, solve for x equals 2, x equals 4. Those are your x-intercepts. Those are your x-intercepts. Meaning, on your x-axis, look for 2, look for 4, make a point. So, if I'm looking for 2, make a point right there. X equals 4, make another point right there. Your parabola is going to go through those points. Okay, so that was factored form. The factored form gives you the x-intercepts. Now, let's look at standard form. We are given that the standard form is y is equal to 2x squared minus 12x plus 16. We already did this. If we go back to, let's see, what section was it? Section 5. We said that the last number gives me y-intercept. Well, this is written in standard form. So standard form, the last number is 16. It's going to give me my y-intercept. And it's always 0, comma, y-intercept. So my y-intercept is only we're only going to be looking at the last one. Erase everything else. That is not important. My y-intercept is always 0, comma, whatever number this is. 16. So, since this is my y-intercept, we're not going to go on my x-axis. We're going to go on my y, and we're going to look for 16. I'm out of bounds. It's going to be, let's say 16 is right there. 16 is right here. I don't have enough space, but 16 is right there. Okay, that's it. Now for the vertex form. The vertex form, I get y is equal to 2x minus 3 squared minus 2. For my vertex form, the only two numbers that are important for my vertex, it is this number, this number. This 2 in front, it does not matter. Only those two numbers. The inside is a liar, liar. Do the opposite. What is the opposite of that? X. Oh, what am I doing? What am I doing? The opposite of this, that negative 3, it's going to be a plus 3. And then here, this negative 2 is not inside my parentheses. So it is not a line. It stays as negative 2. Plot that vertex. So we're going to do 3, 2, 3, and negative 2. Right there. And there we go. We plotted the x-intercepts, we plotted the y-intercepts, plotted the vertex. Something else I want you to do, besides what it's telling me here, is draw your axis of symmetry. Your axis of symmetry is always going to go through your vertex. And now we're just going to connect it. You know, this is going to go something like this. And then to hit 16. So this 16 just reflect it over. It is 1, 2, 3 away from my axis of symmetry. So when I reflect it, 1, 2, 3, it's going to be 1, 2, 3. And there we go. Using the 3 forms, I was able to graph this correctly. Okay, I'll leave question 32 as an example. Hopefully this video helps you. Hopefully we take advantage of the problems I left empty for you guys. I gave you guys some hints on this one. This one. Oh, I should have done this one instead. Okay, well, that's fine. For this one, this is a downward. So we know it's going to be going downward. And the reason I know that is because these are all negative. And also because it tells you. But anyways, actually, let me help you guys out on this one. I'll factor form when it is written like this. Actually, I'll just give you some notes up here. Set this equal to 0. Let's see. Let me write it in marker. So this one, x minus 2, set it equal to 0, and then solve for x, meaning x equals positive 2. This one, x minus 6, set it equal to 0, get x equals 6. Those are your x-intercepts. Standard form. You don't even need all this. The only thing you need is that negative 12. That is 0, negative 12. That's your y-intercept. Vertex. The intercept. Intercept. It's a liar. Liar. It's a mentiroso. We do not do negative 4. Do not do negative 4. Do not do negative 4. You can do a positive 4. And then that 4 there. You already have, and there you go. You already have everything you need to graph. Okay, actually I'll just finish it up. So 2, x equals 2, that is one of them. X equals 6, that's another one. Your y-intercept, x equals, your y-intercept is 0, negative 12, negative 12. It's not in the graph either. It's going to go down, it's going to be somewhere right here. That's going to be your y-intercept. Your vertex is 4, 4, so 4, 4. Connect these. Well, first, you got to make your axis symmetry. Here, your y-intercept is 1, 2, 3, 4 away. So meaning when I reflect it, you're going to do 4 away. 1, 2, 3, 4. Okay, and it should look super symmetrical. And there you go. And we are done. Okay, hopefully this helps you guys. Good luck on your tests. Good luck on your finals. Okay.